Hello everyone, welcome back to online survey video tutorial on applied hydraulics. So today we are discussing about the module 5, that is the reaction turbine and the pumps. So in the first class we are covering the introduction to radial flow reaction turbine. So coming to the radial flow reaction turbine introduction, so the definition, as you say in the name itself, the radial flow means the water enters in the radial direction. So reaction turbine, about the reaction turbine we have already discussed in module 4 while discussing about the classification of turbine. So based on the energy which is available at the inlet, so it is classified as a impulse and reaction turbine. So if only kinetic energy is available at the inlet of the turbine, then that is called the impulse turbine. Reaction turbine means, so if the water possesses both the kinetic and the pressure energy at the inlet of the turbine, that type of turbine is called the reaction turbine. And here, as I told, radial flow turbine means, so water flows in the radial direction, and so this radial flow reaction turbine is subclassified into inward radial flow turbine and outward radial flow turbine. So let us come to this inward radial flow turbine and outward radial flow turbine, so in detail later. So, and the example for inward radial flow is an old Francis turbine. And coming to the reaction turbine, so as I've already mentioned, at the inlet of the turbine, so the water has both kinetic and pressure energy, then that type of turbine is called reaction turbine. So reaction turbine is best suitable for high flow rate with a low head situation. And here the rotation of the runner or rotor is partly due to the impulse action and partly due to the change in pressure. So that's why it is called the reaction turbine. And also, so in this particular case, the penstock pipe will feed the water to a row, to a row of fixed blades through the casing, and so where that blades, whatever the fixed blades, that will convert the pressure energy into the kinetic energy, so before it entering into the runner. Okay, so before entering into the runner itself, so the fixed blades will convert a pressure energy into kinetic energy, then only the runner will start rotating. So thus water entering the runner will be having both kinetic and the pressure energy. So that's why it can rotate with a very high speed. So, and the water leaving the turbine is still left with some energy, that will be both the pressure and kinetic energy will be there. So after leaving the turbine also, the water will be having some amount of pressure and kinetic energy. So since the flow from the inlet to tail race is under pressure, so the casing is absolutely necessary to enclose the turbine, because because of that high pressure, so there may be some accidents and breakages of the blades. Okay, so it will create an accident. So to avoid that, the casing is very much necessary. And also the example for this radial flow reaction turbine is Francis and a Kepler turbine. So coming to the parts of the radial flow reaction turbine, so you can see the figure here. So the main parts of radial flow turbine. So the first one is a spiral casing, you can see it, and water will be feed from the penstock through the pipe, you can see, to the casing. So water from penstock will be carried out. You can see the direction arrow of the flow of water. So you have a spiral casing. So spiral casing means, you can see here, so there is a gradual decrease in the cross-sectional area of the casing with respect to the flow. And after that, you have a guide wheel. You can see here, this is a guide wheel where fixed vanes are fixed. So whatever the guide wheel will be having a number of fixed stationary vanes which are not moving, and around the guide, like after the guide wheel, you have a runner part where the vanes are moving around the runner. So you'll be fixed a number of moving vanes. So these are the main parts of radial flow reaction turbine. So let us see in detail the components. So the first one is a casing. Okay, so casing, the water will be withdrawn from the reservoir or from the sump from the reservoir through the penstock, and it will enter into the casing. So with a spiral shape, so you can see the casing is of spiral shape, so in which the cross sectional area is gradually decreasing. You can see there is a gradual decrease in the area, and so that the runner will be completely surrounded by this casing. And the material of this casing, usually it is a concrete or cast steel or a plate or steel. And you can see here typical casing, how the typical turbine practically will look like. You can see here. And coming to the second component, that is a guide mechanism. You can see here, this is a guide wheel, which is called the guide mechanism, where a number of stationary vanes are fixed, means whatever the blades which are fixed on this guide wheel, so which will be stationary, means which are not moving. So guide mechanism consists of stationary circular wheel, so around the runner, and these the stationary guide vanes are fixed on the guide mechanism. So what is the purpose of this providing a guide wheel? See, it will just direct the water and to the runner. Okay, the guide vane allow water to strike the vane fixed on the runner without any shock at the inlet. So these guide wheel will guide the water so that the water enters the runner without any shock. Okay, so that is the purpose of providing this guide vane. So the next component, here you can see the clear picture. So like this is the runner part. You have a movable plate here. So this is the guide wheel and the stationary guide vanes. And the next part of this radial flow reaction turbine is the runner part. So you can see it is a circular wheel. So here, so where a series of radial moving curved vane are fixed, and here the surface of this vanes, whatever these moving vanes are there, so the surface is made very smooth, so to avoid the losses. So if the surface is smooth, then there is no losses. And the radial curved vanes are so shaped that the water enters and leaves without shock. So whatever the vanes which are fixed on the runner will be made in such a way that there is, while entering and while leaving, there is no shock. Okay, so and the material is used cast iron or a cast steel for the runner. And the next component, the part of this turbine is a draft tube. We can see here. So this is how the draft tube will look like. So what happens? So the pressure at the exit of the runner. See, this is the runner part. So at this part, the pressure of will be more than atmospheric pressure. Okay, so at the exit of the runner, so usually the pressure will be greater than the atmospheric pressure, so that you cannot discharge that particular water directly into the tail race channel. So there may be some accidents if you directly discharge that water from the exit of outlet of the turbine, which has a very high pressure. So that's why, so a tube or a pipe of gradually increasing area is used to discharge the water from the turbine to the tail race. So that tube of increasing area is called a draft tube. You can see here. See, draft tube is a pipe of a gradually increasing area, so which is used to discharge water from the outlet of the turbine into the tail race channel, so that there is no accidents or erosion because of that high pressure of water which is coming out from the turbine. So that is the purpose of a draft tube. So this is a typical hydroelectric power plant. You can see here, this is a penstock which is used to withdraw water from the reservoir, and that water is fed to the turbine part. You can see here the turbine part, and this is the runner part. This is the shaft. So where the shaft, the runner is connected to the generator. So this is the generator. The shaft of the turbine is connected to the generator, so which is used to generate electricity, and this complete assembly is called the powerhouse. And you can see this is a draft tube which is used to discharge water, so without shock, to the tail race channel. And this is also one of the typical hydroelectric power plants. So you can see here clearly where the turbine is there, where penstock is there, generator, powerhouse, draft tube, tail race channel, everything. So we'll get a clear picture here. And already mentioned, like the radial flow reaction turbine is subclassified into two types, that is inward radial flow turbine and outward radial flow turbine. So inward radial flow turbine, you can see here, this is how the inward radial flow turbine will be there. So you have the shaft here, the central part is the shaft, and after that you have a runner here, and you have around the runner you have a guide vane. Okay, so where the stationary vanes are fixed, on the runner you have a moving vanes. So here the water enters from outside to inside. You can see the direction of the arrow, the direction of the flow. So the water enters from outside to inside. So that particular radially, so again in a radial direction. So that particular turbine is called inward radial flow turbine. So if the water enters, so outside to inside radially, that is called inward radial flow turbine. And here in this particular case, so the outlet of the runner, see this is the outlet of the runner. So the outlet of the runner will act as the inlet, and the outer diameter of the runner will act as the inlet, and the inner diameter, so that is D1 acts as a inlet and D2 acts as the outlet. You can see here also. So the water is leaving. So D1 acts as a inlet and D2 acts as a outlet. So that is the inward radial flow turbine. So the second type is outward radial flow turbine. It is reverse of inward radial flow turbine. So here the water enters, so from inside to outside radially. So you can see here, so the water, the flow, so the rest everything remains same. You have a runner, around the runner you have a guide wheel. So only the thing is sorry, here it is different, like so first you will be having guide wheel, so after that you will be having runner, because so the water is entering from inside to outside. Okay, so you'll be having a guide wheel first. Around the shaft you will be having guide wheel where the stationary vanes are fixed, and around that you will be having a runner with the moving vanes. So and the water enters from inside to outside radially. Okay, that particular turbine is called the outward radial flow turbine. So in this case, see D1 will act as the inlet and D2 will act as the outlet. Okay, so that is all about the introduction to radial flow reaction turbine. So let us continue in the next class. Thank you all.